Okay, folks, welcome to our next little mini lecture here. I'm going to be talking today out of Chapter 3, which is Basics of Networking. And in networking, computer science folks are always talking about the OSI model, which has 7 different layers. Okay, if you think of the top layer as being the applications that we run, and the bottom layer being the actual copper and the cables and the network card and really the physical layer. Our discussion today is going to be somewhere in the middle there. Okay, so we're not the very top server related level. We're not the very bottom. We're talking about cables. All right. So talk about about networking. There's really one standard that the world has embraced. Standards are great. If you get everybody agreed upon the same standard, then communication can take place. All right. So the one language we use, or the one protocol we use, is called TCPIP, and it hasn't always been that way. But with the advent of the internet and the necessity to have everybody communicate, we've all agreed upon TCPIP. So the entire world's running this. Now, granted, there are some other protocols out there, but this is the most common. All right. So with this protocol, there is a IP address that's attached to every single computer. I think we've talked about this earlier in our class, that every computer has its own unique IP address. And in order to communicate and function on the internet, you have to have a unique address. All right. We also take, when we send information back and forth between two nodes, or between a computer and a server, or two computers, we break that into what's known as packets. And so that's another standardization. Each packet is the same size. And there's a great analogy, I think it's on page 68 of your textbook, that Snyder uses, which involves postcards. And I'd really encourage you to read that and think it through, because it's a great analogy. All right. So our packets, or our postcards, are standard size. All right. Back to standards again. And on a packet or a postcard, you have to have the sender's address, wherever we're sending it to, the receiver's address, and then somewhere in the middle of that you put the message. All right. And messages are, they can only be the size that'll fit on a single postcard. All right. And so when I want to ship off my 300-page dissertation, really what I need to do, and my computer does this for me, is it writes down everything out of that particular long document, and it rewrites it into postcards. All right. So my 300-page dissertation might be 10,000, 50,000 postcards, and it drops them all in the mail. Okay. And then they receive the receiver on the other end has the ability to put them all back together. Okay. And that's what happens and it's layer 3 at the IP level, or the protocol level of our basic networks. Okay. And here's another little slide here. I think this is a slide on page 69 that shows your computer, destination computer. And then there's a bunch of different routers in there that route your packets or route your postcards, just like the mail system. If I'm going to take a postcard of my mail from here to New York, it doesn't go directly to New York. It might go out to Seattle first, all right, where centralization takes place. And maybe everything from Seattle goes to Chicago. And then lastly, it goes from Chicago to New York. Okay? So a lot of analogies with the Postal Service there. We move packets all sorts of different ways. We might move them electrically, electronically, or optically. It depends if we're using fiber optics, if we're using satellite, if we're using cell phones, if we're using copper wire too. Okay, so the technology, that's the lower layer. I've mentioned the OSI model. That happens down at layer 1. Okay, how we move it. But for the packet layer, which is in the middle, they don't really care. It can move equally as effective, regardless of whether it goes across optical lines or fiber optics. Actually, that's the same thing, isn't it? I'm sorry, optical lines or copper line. All right. So as far as some other terminology here, we have wide area networks and local area networks. When we're on campus here, it's generally considered a local area network. In other words, everything's within a certain geographic region. And we have, and you guys will see some of these tools. We'll have a little activity where we'll ping, we'll trace route, and we'll kind of see where there's gateways. Gateways connect local area networks, all right? And we have a couple gateways. It tends to expand to a wide area network, okay? And between each of those routers, that's known as a hop. So going from one LAN to another, sometimes we go, how many hops away are you? How many local area networks away are you? Here's this figure out of your text again, figure 3.8, shows an example of a trace route where we look at the communication between two differing, sender and receiver, all right, and the different paths that a person might take. You take a look here, they're trying to get to Switzerland, I believe, right? And they route it through, it goes to Seattle, and then Cyprus, and then out to Frankfurt, Geneva, and then finally makes it to its destination in Zurich, okay? So you take a look at that, and we'll do a little bit of work in the classroom with trace route. All right? So Ethernet, okay, is a channel that winds past a set of computers. So Ethernet has a limited distance, okay? There's only so far that signal can go, all right? As opposed to the Internet, we have all sorts of repeaters, routers, switches, hubs are the terms we use there. But for strictly an Ethernet, you might think of it as your local area network. All right, and this is going to be significant when we start identifying different characteristics here. Okay, so here's the original diagram. You take a look at that. But here's the analogy, and I think this again is a very, very good analogy. So with the Ethernet protocol, and this is what's running on my local area network, we have the analogy is a conversation at a cocktail party. All right, when one person talks, all right, it's very centralized. You have nice etiquette. Only one person at a time talks. That person's talking. When they're finished, there's a pause, and then maybe somebody else comes up with something right after that. Okay, so there's a convention here, and this is the way Ethernet works. So if nobody is talking, and we listen on the line, we can go ahead and talk. We can send packets across there. All right. If somebody's talking, we have to wait till they are done, and that's the way a local area network works, or Ethernet works. Okay. Versus a decentralized strategy, excuse me, like the Internet, we just throw all the packets out there, all right? And so it's not like the nice dinner party, okay? A computer starts to transmit. If another starts to transmit at the same time, they hear garbled messages, both stop for a random time and try it again, all right? So that's a really decentralized scheme there, all right? So Internet uses point-to-point networks to implement point-to-point communication. Ethernet uses broadcast, okay, see a difference? Internet allows multiple communications to take place concurrently, while Ethernet allows only one communication at a time. All right. Let's shift gears here and just briefly talk about how we can get connected to the Internet. And I think that this is broadly descriptive or generalizing is the three ways that the average person gets connected. Okay. One, we get an ISP. All right, an ISP might bring in a DSL line. That's technology that's widely implemented through our traditional landline phone service, or through our cable. Okay, we might use one of the cable companies, and that's how we get our Internet, and that's known as an ISP. All right, second common method that we get connected to the Internet is through a local area network. All right, and this typically takes place in more of the office environment or larger enterprises. So we have some sort of route out to the Internet already established by our institution, and we just have to plug into our local area network. Okay, we could also find us at home. All right, but again, generalizations here. All right, last one, and I think this is becoming more common. And my prediction here, if you're listening to this lecture 3 years from now, you might find this false. But right now, my prediction is the tablet PC. And the Android phones and your iPhones are just reinventing the whole Internet experience, because now we have it wherever we go. We don't have to worry about our ISP. We don't have to worry about a local area network. Everything is through our wireless cell phone provider. Okay, so this is wireless. We also find this too if you go in a coffee shop. We have a wireless hotspot. Actually, go anywhere on campus, you hit the wireless hotspot. All right. So again, it's a different, and there's different characteristics here because we are wireless. We're totally mobile. All right. Now that mobility might stop, like 802.11 wireless, which is most of our coffee shops and around campus. if you leave, there's generally an area of about 300 feet. All right, and if you start to get close to that 300-foot boundary, you're going to find your bandwidth drops. All right, you don't get as good a performance as when you're right next to it. And then as you walk out of the building and get in your car, you might not have any access at all. Okay, versus your cell phone, really interesting technology, because now, gosh, I could be standing up on top of Mount Sentinel at the M, and I have, I can work just as readily there as I can if I'm indoors. All right, and here's just a little diagram that kind of shows all those different things coming together.